All right, guys, I'm going to work through the review that I gave y'all. Try to do my best to explain the questions as I go. Of course, just fast forward to the ones you need to see. Yeah, let's see what we're doing. First, this picture is for a lot of questions, so we need to understand the picture. It's not the best picture, honestly. This was supposed to be solid the whole time. You can see some of the dots still showing up behind the solid line. But it should be, sorry, that portion of it should be solid, and then it turns dotted past the letter B. Just as a reminder of what this would be, this is not the exact same picture, but it's similar. The dotted part means it's behind. So like in this picture, the line DE here, would it ever hit the line AB? Do they ever hit? Well, it looks like they might cross, but we can change the perspective in this program. We can tell, hey, it doesn't actually do that. That dotted line means that it's going through the other thing. In other words, it's solid here where it's above, and it's dotted back there where it's behind. You can see point C is well below, point A is well above that gray plane, and the dotted lines let us know that. Now this line back here, line BE, it does intersect at point B. So that's a spot where solid meets solid. It gets dotted after point B. So point B is the spot where it actually goes through the plane. And that's kind of the same idea that's happening on this first picture. So point X would be above it, point Q would be below the plane. The rest of them are on solid lines, they're on the plane. So let's keep that in mind as we answer the questions. All right, plane P, it's plane P in the corner there, contains line XQ. Well, we just talked about how that is false. XQ goes through the plane, but it is not on the plane. Plane P contains Q. Again, that is false. Q is below the plane. That's what the dotted lines tell us. Line DC is in plane P. Yes, this line DC is solid the whole time. That's a yes. Another name for line AC is line CB. Well, line AC would be A through C, would hit all those points. Would it also hit B? Yes, B, C, and AC are the same line. Not the same line segment, but they are the same line. A, B, and C are non-collinear. That's 3 points, so let's check them out. A, B, and C do form a line. Collinear means in a line. Non-collinear means not in a line. They are collinear. So that is a false statement. A, B, C, and D are coplanar. A, B, C, well, that's a line, so it doesn't matter where the other point is. Remember how many planes go through a line? The answer is infinite, so I don't care where the other point is, but can I make one big triangle with D over there? Yes, I can. Triangles are flat. We're good. We be good. So A, B, and C are coplanar. That is true. D and A are collinear. I do not need the picture. 2 points are always collinear. 2 points are always collinear. So I don't need the picture, but DA, could I draw the line? Yes, I could. Collinear means they are on a line together. It does not mean that the line must be drawn. CX, same thing. Can I draw a line containing C and yes. It doesn't matter whether it's drawn or not. It's there. We can draw it. It can be done. They are collinear. Now, A, B, and D, that's 3 points. Can I hit A, B, and D with one line? No, I can't. I would need at least 2. So those are non-collinear. 3 points, non-coplanar? I don't think so. Remember, 3 points are always coplanar. But in particular, A, B, and X. A, B, even though X is above, that's a triangle that would go above, that goes through the plane. We could make that in the other program, I promise. The plane is not drawn, but it is there. Let's just go take a look at it real quick. It'd be like me drawing a plane that goes through A, B, and E in this picture. Yes, I can do that plane. It goes through the shape. That's what it would look like. Yes. Now, would it hit point D? No, it wouldn't. Point D would be in front. X, A, B, and C are coplanar. Well, A, B, and C are all in a line. So A, B, and C are all in a line. Does X, yeah, that's the same plane we just did. That's, oh, wait, no, sorry, that was A, D, and X last time. Sorry, so it wasn't the same plane. But that's a different plane. Yes. That's the plane that I just did in the other program. Sorry about that. Yes, true. Every plane which contains A and B must contain C. Well, remember, planes go forever, lines go forever. Well, A and B, every line that has A and B is going to get C. So every plane, whether it comes from D, if it comes from D, it's going to hit all of them. If it comes from X, it's going to hit all of them. Yes, because it extends forever. Even if you draw it a little bit short, like if I said X, A, and B, well, that triangle extends. It goes up the line. Like they extend forever. They don't stop going. So yes, if it hits A and B, it's going to get C because it's going to extend to get C no matter how it is. Line J, remember we can name a line by the small letter at the end. So line J, that's like that line that goes up and down and through the shape. Intersects line DC. Well, at that spot, they are dotted. That's behind. So no, it doesn't. Plane ABX. ABX is this plane that goes up in the air. Intersects P on the line AC. Yes, that's the intersection point. So going back to this program, even though I select just a few points, like it's going to hit the entire line. So it's going to keep going. And remember that the intersection of two planes is a line. So like on this one, that blue plane, it intersects on the entire line, BE. If I put another point on the line, it doesn't matter. So plane ABX intersects on line AC, true. Line AB contains point D, no. Point D is not on this line AB. Line AB would have to turn to get D. That is not on the same line. X is between D and C. Between they have to be collinear to be between. This is the line DC. Is X collinear with D and C? No, it's not. So it's not between. True, I don't even need a picture. True, I don't even need a picture. Why? 3 points have to be coplanar. 1, 2, 3 points have to be coplanar. D, B, and X would be a plane going this direction. Got it, no problem. What would it look like in the other picture? Could I go over here? Could I hit A, D, and F? Sure. I don't know if that's the equivalent, but yes, any 3 points can have at least one plane go through them. A, B, and X, well, we've done that one a few times. So yes, yes, yes. Sometimes, always, or never. 3 points, if 3 points are collinear, 1, 2, 3, they lie in exactly one plane. No, never. They lie in infinite planes. Infinite planes hit a line. We've talked about that a lot. If 3 points are collinear, same 1, 2, 3, then they are coplanar. Well, yes, they're coplanar. What does that mean to be coplanar? It means to lie in at least one plane together. They lie in infinite planes together. Yes, they are coplanar, but it's not exactly one plane. No, it's infinite planes. If 2 planes intersect, their intersection is a line always. Just going back to this picture, what happens when 2 planes hit each other? When 2 planes hit each other, it's the entire line. Even if it's not drawn, like here, that plane is DF. It's the entire line. The blue plane they drew follows that line, DF, the whole time. You can kind of see it. Yeah. Opposite rays make a line. Well, that's the definition of opposite rays, yeah. If this is one of the rays, the opposite ray has to start at the same place and go the opposite direction. So yes, opposite rays make a line. Supplementary angles are linear. I should have said maybe a linear pair. They can be, but they don't have to be. So if I draw something like this, where this is 30 degrees and this is 150, yeah. But what if I have over here 150 degrees and over here 30 degrees? Are those a linear pair? No. So supplementary angles don't have to be a linear pair. Now flip the order of that. If I said a linear pair must be supplementary, yes. Linear pairs have to form a line. Lines have to be 180 degrees. So do linear pairs have to be supplementary? Always, yes. Do supplementary angles have to make a line? No. The only thing supplementary angles have to do is add up to 180. 2 angles, 180. That's it. Vertical angles are adjacent. Those are competing definitions. No. Adjacent would be like angle 1 and 2, side by side. Vertical would be like angle 3 and 4, opposite. You cannot be side by side and opposite. You can't be both those things. Adjacent angles are congruent. Could I draw adjacent angles that are the same size? Could they both be 10, both be 20, both be 30? Sure. Could I draw adjacent angles that are different sizes, like 20 and 30? Sure. Adjacent just means side by side. That's it. All right, so far so good. The coordinates of the endpoints of the diameter of a circle. So we got a circle. The diameter, remember, goes through the circle from edge to edge, and it goes through the center of the circle. It's the longest part of the circle. So if those are the endpoints of that segment, which I didn't really draw it correctly per se, but those are the endpoints, find the coordinates of the center of the circle. Well, the center would be the middle. How do you get the middle? Well, the easiest way is to add and divide by 2. So 5 and -7, we add those. Now remember, it's like plus -7, so if you want to kind of see that, it's 5 plus -7, technically. We're adding them, but what is plus a negative? It's the same thing as minus, so I'm going to write that as minus, divided by 2, comma, and we're looking at just the x's, right? You can't do an x with a y. This is an x, this is a y. This is an x, this is a y. It's the middle x, we add them, divide by 2, and then it's the middle y. We add them, 8 and 2, and divide by 2. And what do we get when we add those and divide by 2? We get -1 and 5. How long is the radius? Long, length. That's a distance. Remember that distance is Pythagorean theorem. We've talked about that quite a bit. So where does the radius of the circle? Well, it's from the end to the middle. And it doesn't matter which end. So I'm going to pick one of these ends. It doesn't matter which one. I'm going to do 5, 8. And I'm going to compare it to -1, 5. So what am I looking at? I'm looking at the x's. How far is it from 5 to -1? That is 6. We square it. So remember, it's like a right triangle on a graph, right? Like you're making a right triangle. How far apart are the x's? That's like your a. How far apart are the y's? That's like your b. We're doing a squared plus b squared. So we look at the y's, 8 and 5. Those are 3 apart. We square it. And so it's the square root of 30. That would be 36 plus 9. But I would just type it straight in our calculator. Right now, we're allowed to just use the calculator. That would be 36 plus 9. Oops, my calculator turned off. It doesn't matter. That is going to be the square root of 45, which simplifies to 3 root 5. So how long is the radius? The radius is 3 root 5. Another way you could have done it is you could have found the distance between the two ends, but then you'd have to divide your answer by 2. Still good, though. Still works. All right, y is the midpoint of xz. Find the coordinates of z. So we have a line segment. It's called xz. And y is the middle. Tick marks let us know that those are equal. Over here, we have the coordinate 0.4, comma 3. Here we have the coordinate -1, comma 5. And we're looking for this xy coordinate. There's a couple ways to do it. My favorite way is to just get the distances. Look at the x's. How far is it from 0.4 to -1? How far have you traveled? You start at 0.4, you go to -1, you've done -1.4. So I'm going to do another -1.4. -1 minus 1.4 would be -2.4. So that's going to be -2.4. Same thing with the y values. 3 to 5 is +2. So I'm going to add another 2. And there's my answer. The endpoints of A, B are that if P is 1/4 of the way from A to B. So so this one's a little bit trickier, but it's a lot like what we just did. We're going to look at the x's. How far is it from -2 to 6? That is +8, but we're not going the whole way. How far are we going? We're going 1/4 of that. So 1/4 of 8 would equal 2. So I'm going to do -2. We're starting at -2, and I'm going to add 2. That's going to land me at 0. Then I'm going to do the same thing with the y values. 7 to -5, that's -12. So that's going to be 1/4 of -12. That's going to be -3. So what I'm going to do is I'm going to start at 7, and I'm going to do -3. That's going to land me at 4. My answer is 0, 4. Boom. Find the perimeter of this triangle. We're going to do distance formula 3 times. Good practice. So I'm going to start with A to B. I'm going to go quick through this. A to B, 7 to -1 is 8. We're looking at the x's. We square it. -4 to 2 is 6. We square it. And I know that the square root of that's going to be 100. That's going to be 10. From A to C, we have the square root of 7 to 5. That's 2. We square it. From -4 to -6, that's 2. We square it. So that would be 2 squared, 2 squared. That's going to be 2 root 2. And then from B to C, we have -1 to 5. That's 6. We square it. 2 to -6, that's 8. We square it. Ooh, that's also 10. So in this particular one, we have 10, 10, and 2 root 2. We add those together. 10 plus 10 plus 2 root 2 is 20 plus 2 root 2. And that's our perimeter. So there's 3 distance formulas. Practice that. Get good at that. If angle A is 40, the complement would be 50. 90 minus 40, 180 minus 40. Here, no complement. And this would be 78. On this one, 90 minus 30 minus 2x would be 90 minus 30 plus 2x. Over here, 180 minus 30 minus 2x would be 180 minus 30 plus 2x. So this would be 60 plus 2x. This would be 150 plus 2x. All right, 2 lines intersect. Angles 1 and 3 are vertical. Angles 2 and 4 are also vertical. Something like that. They gave us angle 2, clocking in at x squared plus 30. We got us angle 3, coming in at 3x plus 20. So what do we know about those 2 angles, 2 and 3? They have to add up to 180. X squared plus 30 plus 3x plus 20 has to add up to 180. So x squared plus 3x plus 50 has to equal 180. So x squared plus 3x minus 130 has to equal 0. First job is make one side 0. Now we got a factor. We did this last time. There's a factoring video, but the premise is the factors of 130 that subtract to equal 3. So we know that those are going to be 13 and 10. Plus 13 and minus 10 would give me a positive 3. So what would make those zeros? Negative 13 and positive 10. We got to plug them in and check them out. If I plug in positive 10, I would get 100 plus 30. Could that angle be 130? Yes. Plug in 10 here. I get 30 plus 20. That would be 50. Checks out. So how big is angle 1? Angle 1 would be 50 in that case. Let's try the other answer, negative 13. Negative 13 squared plus 30, that would be 169 plus 30 would be 199. Already, it can't work. It can't work. 3 times negative 13 plus 20, that'd be negative 39, be negative 19. Doesn't work. That one's out. So 50 is the only thing that our answer is. So our final answer is 50. Ooh, okay, we're getting there, guys. Challenge question, the supplement of an angle is, that's 180 minus x, we've talked about this a lot, is 36 less than, twice the supplement of the complement. Let's go to the side here. The complement would be 90 minus x. The supplement of the complement would be 180 minus the complement. That would be 180 minus 90 plus x, which is 90 plus x. This is a hard question, and it's twice that, 2 times the supplement of the complement. So that's 180 minus x equals 180 plus 2x minus 36. The 180s cancel out. Move the x over, that'd be 3x equals 36, x equals 12. So the supplement would come out to 168. I know I'm going fast. So you can keep watching it. You can rewind it if you need to. The measure of the supplement of an angle, that's 180 minus x, is 30 more than twice the measure of the angle. So that would be 3x equals 150. So x equals 50. Find the measure of the angles. That'd be 50, and the supplement was the other angle they mentioned, 130. The complement of an angle is 200, so that'd be 90 minus x is 280 less than 3 times the supplement. 3 times the supplement. So that would be 300 would be 540 minus 3x minus 280 equals 90 minus x. So that would be 2x. 540 minus 280 minus 90 would be 170. So what does x equal? X equals 85. So the measure of the supplement would be 95. The supplement would be 95. All right. Measure of angle 1 is 3x plus 11. Measure of angle 2 is 5 minus 2x. Measure of angle CFE, all of that is 9x plus 24. And they tell us that FC is a bisector. So all of this is equal to all of this. So 3x plus 11 plus 5 minus 2x has to equal 9x plus 24. Those have to be equal. So clean that up. That would be x plus 16 equals 9x plus 24. 8x equals negative 8. So x equals negative 1. Plug in negative 1. This would be 8. That'd be 7. And this would be 15. They also tell us it's the bisector for BFD. So if that's 7, then this is 7 and this is 8. So the measure of angle 1 is 8. The measure of angle 2 is 7. And the measure of angle CFE is 15. All right, I'm going to pause here. I'll finish the rest of them on a separate video here in a second.